In this lesson, we're going to review the cosine law. Much like the sine law, the cosine law is used when you're solving for the measure of a missing angle or side in a non-right angle triangle. The cosine law is given at the beginning of your note. And of course, that formula will change slightly depending on the labels of your triangle. So it obviously will not always be A, B, and C. But that is the general pattern. So a squared equals b squared plus c squared minus 2bc times the cosine of angle A. There are two classic cases for which we can apply the cosine law. One of those cases being when the lengths of all three sides in the triangle are given. So we will represent that in our picture here by putting a dot along each side. So that would be the given pieces of information. And the other classic case is when we have two sides and a contained angle. So that would be having, say, this side and the angle in between them. And I've given you the hint here, the Pac-Man hint, to think of the Pac-Man symbol. So we would have, again, the two sides and the angle in the middle. Okay? Now, let's go through an example here of using the cosine law to find the measure of a missing angle as well as a missing side. So in our first example, it says in triangle PQR, P is 8 centimeters, Q is 7 centimeters, and R is 10 centimeters, and we are asked to determine the measure of angle Q. Since it's angle Q that we're looking for, we're going to put side Q on the left-hand side of the triangle. Remember in the formula that whatever side is on the left side of the equal sign will correspond with the angle at the end of the formula. So in this case, our formula will be Q squared equals P squared plus R squared minus 2P R times the cosine of angle Q. Then we fill in our three side lengths. So Q is 7, so we'll have 7 squared equals 8 squared plus 10 squared minus 2 times 8 times 10 times the cosine of angle Q. We'll do some evaluating. So 49 equals 64 plus 100 minus 160 times the cosine of Q. And right here is where we need to be careful. Because the most common error that I see with the cosine law is that people think that the next step would be to do 64 plus 100 minus 160. But that would not be right. What you need to remember is that this negative 160 is attached, as in it's being multiplied with, cosine Q. So multiplication comes before addition and subtraction. So it would not make sense to subtract the 160 from the 164 we'll have here because there's multiplication happening between the 160 and the cos Q. Okay, so we cannot combine the 164 and the negative 160. What we do instead to get rid of the 164 on both sides is we subtract it. So we'll have 49 minus 164 on the left equals negative 160 cos Q. 49 minus 164 is negative 115. Let me write that a little clearer. Negative 115 equals negative 160 cos Q. Now we're trying to get cos Q by itself, so we'll divide by negative 160. Okay, on the left-hand side, when you turn this into a decimal, keep several digits. So 0.71875, we'll say. At this point, you could keep all of the digits on your calculator anyways. There's no need to retype that number. And then because you're solving for the angle, don't forget that you'll use the inverse cos button again. And from that we can determine that angle Q is 44 degrees. Okay, now in part B, we are asked to find the measure of side H given the side lengths G and J. So in your question, it says that G is 5.1 meters long, J is 8 meters long, and angle H is 60 degrees, and we're finding the length of side H. So again, we'll start with the side that we're looking for. So H squared in this case equals G squared plus J squared minus 2GJ cos H. Now we'll fill in the given information. So H squared equals 5.1 squared. Let's fix that. Plus 8 squared minus 2 times 5.1 times 8 times the cosine of 60 degrees. Okay, so solving for a missing side length is a little more straightforward because we could just type that all into our calculator, even all at once. And you might want to practice that to make sure you're hitting those keystrokes correctly, but I believe that comes out to 49.21. And then all we have to do is take the square root of that. And we can say, therefore, H is approximately 7 meters long. Okay, moving on to our next example. This one says two sides of a parallelogram measure 8 centimeters and 10 centimeters. The longer diagonal measures 15.5 centimeters. Determine the angles of the parallelogram and then determine the length of the shorter diagonal. So let's have a look at part A first of all. So we are asked to find the angles of the parallelogram. So let's draw ourselves a picture of this parallelogram. All right, it says the sides of the parallelogram are 8 centimeters and 10 centimeters long. And the longer diagonal, so that would be this one here, measures 15.5 centimeters. Okay, and we were asked to find the angles in this parallelogram. So what we're going to do first is consider the triangle created by half of this parallelogram, created by the diagonal, I guess we should say. And we're going to use the cosine law to find the measure of this angle down in the corner. So I think for simplicity, let's label this triangle as triangle A, B, C. Okay, so essentially we're trying to find the measure of angle C. So then in our cosine law, we would start off by writing C squared equals A squared plus B squared minus 2AB times the cosine of angle C. And then we'll fill in our three side lengths. Side C then is 15.5 centimeters, A is 8, and B is 10. There we go. Minus 2 times 8 times 10 cos C, which is what we're looking to find. All right, 15.5 squared is 240.25 equals 64 plus 100 minus 160 times the cosine of angle C. Now remember from our last example, once again, we're going to combine our first two numbers, but not the 160, because it is attached to, that is being multiplied by, the cos C. So this, in other words, you could think of as all one term. So what we do instead is we subtract the 164 from both sides. Okay, so that gives us 76.25 on the left. Our next step will be to divide both sides of the equation by negative 160 to get cosine C by itself. Keep several digits after the decimal point. The more you round, okay, the less accurate your answer will be. So keep several digits there, and as I said, you could actually just keep them all on your calculator screen, because your very next step will be to find cos inverse for that value anyways. And so we find out angle C is approximately 118 degrees. Okay, so let me just draw a new picture here so I don't get too confused in the other one. So now we're saying this angle at the bottom is 118 degrees, which means this angle at the top is also 118 degrees. So now we need to find the measure of these two angles. And since we know that the angles in a quadrilateral add up to 360, we could take 360, subtract 2 times 118 degrees, and then with the result we'll have to divide it by 2, because of course we know there are two angles that then add up to the remaining amount. So that tells us that each of those smaller angles measures 62 degrees.